This is Magnus, and this is a shortened version of my talk on the last 0xFF, and the topic is Let's Get Cracking, and it's about Frida runtime patching. So, software cracking has a bad reputation, but I would argue that it's one of the best ways to get yourself into hacking or reverse engineering. Cracking is typically where you take a closed source app and you modify it in some minor way to work more in the way that you want it to work. All of my demos shall be seen as purely educational examples of what's possible to do with this technique, not necessarily what you should be doing, so keep that in mind. So let's start with the first demo. My first demo, I will play around with the kind of virtual dice thrower app called Dicer. So when you hit the button, it will kind of roll the dice. So this window here is I have my phone connected over USB, and this kind of just records the screen. So let's see what we can find out about the app. So first we will use the Frida trace tool. We give it we tell it to connect over USB. Then we use capital F to tell it to hook the frontmost app, and then we give it a pattern on which kind of classes and methods to hook. So we want to hook, in this case, any class that has a method called onClick, which is kind of the default Android button onClick handler. So let's try this. It found 27 matching onClick methods on different classes. So let's try and click the button. We can see that it catches the onClick call on a class called main activity $6. And $6, that's the sixth inner class of the main activity main class. And we can also find the full package name here. It's the main activity 6. So okay, let's see if we can hook this method and do something fun with it. First, we probably want to figure out something more about the flow. So let's just try and take the see what else is happening on this class. So now I tell Frida trace to trace all of the classes that start with this package name and the class name main activity and all the kind of inner classes of that main class, and also all of the functions of those classes. I found 40 functions in total. So let's roll the dice again. Now you can see a bit more of the flow of the application. So you can see the click, call something like a roll dice, apply settings, then seems to call an event handler called onChanged, which gets the like an integer array, which seems to match the dice thrown. Display some, show dice. So let's see if we can override this sucker here. Right. Let's start with writing a script. So Frida uses JavaScript. So we use something like Java perform and give it a method. So that will be kind of the entry point of this application or the script. Then we want to hook the class that we found. So let's see if we scope it. What do we call it? And it was the first click on change, so it's the first inner class $1. This $1. Now we have hopefully a reference to the class. We want to override the method, so it's the onChanged. We say that we want to add a new implementation of it, and we want to see if this gets called or not. Can also print the argument. Let's now instead of Frida trace, we now use Frida. We tell it to connect over USB. We tell it to hook the frontmost app. We tell it to use the dicer.js script. And we get an error. It seems like the onChanged method has two overloaded methods, taking two different sets of arguments. So one is takes a Java-lang object and one takes an int array. And it was the int array that we wanted to hook. So we do this, so we tell the onChanged, and we want the overloaded method that takes an int array, and we apply our implementation. Save the script. And the nice thing about Frida is just when I save the script, it will just automatically repatch the application without restarting it. So hopefully now, yeah, if I click the button here, we will see that the patch function gets called. And also gets us the array. As you can see now, the dice won't change here, but that's because we don't do anything else in this method. So let's start with just calling the original method here. So we can do onChanged. We still need to tell it which method to call. Like C on Java and stuff, the first argument is always the class instance. And we'll give it the arg. So hopefully no. Let's see if it complained. No. Call again. And now we can see that it actually shows the values that we also get into the method call. So let's see if we can manipulate this argument a bit. So do something like this. And then what's like arg length. Let's loop through the array and give it all 6s. So I save the file. Let's roll the dice. Right, sweet. Okay, so since this is a bit weird, okay, so if you want to do something a bit more funnier, let's do it like this. So we want to pass the phone back and forth. We want just every second throw to perhaps throw a nice value. Do something like this, even odd. So if it's oops, not the same. Save it. And again, all 6s, something bad. 6s, something bad. 6s, something bad. Sweet. So yeah, that was a simple example. Okay, let's start with the second demo. And in this one, I will do some manual middle attack. So that's something I do when I, for instance, see a bit more complicated app doing a lot of network traffic. I want to analyze what kind of request this app is doing and see if I can mess with the request somehow. So the app I want to play with now is TV4 Play. So in this app, I can kind of just try and start something here, and it will always start with this kind of pre-roll showing different ads. So I try and quit this, try something new. And then we'll start with the ads again. So okay, let's see what we can do here. So put this down, and what I've done now is that I've set up a small access point here on this machine. So my phone connects through to this access point. I have a DNS mask that I can fake DNS requests if needed. But right now what I will do is that I will do use a tool called MITM proxy, which performs a manual middle attack on HTTP and HTTPS requests. So in this scenario, I think we will it will use SSL for all of the communication. So if I now try and start something here, it will fail because even though the MIT proxy generates new certificates on the fly, it will use its own certificate CA to sign those certificates. And apparently the TV4 app uses certificate pinning. So that's why we're not seeing anything here. Yes, it just complains that it can't load anything. So this is a good example of where we should start. So what we can do with Frida is we can control all of the logic within the app. So the first thing we want to do now is to kind of remove this certificate pinning that they're doing in the app. And a nice thing with Frida is that they also have a code sharing page on their homepage. So before you start writing something on your own, check this code share site to just see if there are something already there. So for instance, this is a really nice script that kind of takes all of the SSL trust managers that are known using all of the different HTTP libraries and patch those to kind of just accept all of the different certificates regardless of the pinning. So let's try and apply that here. So we again run Frida, we connect over USB, we want to hook the frontmost app, to give it the script called Frida multiple on pinning. Let's see if this works or not. Let's try. Click something. Yeah, here we can see that it starts to check the certificate validation here, and this time it worked. So let's exit that one again and move to our MIT proxy. So now we, since the app accepted the certificate that the MIT proxy generated, we can start to see the requests here, even though they are using SSL. So let's see what we can do. First, it seems to do some GraphQL, so that's probably logging here. Let's see what this is. So we have the request, we go to the response. Here is probably where we have, let's see, so this is it looks like what they call the bumpers are the kind of pre-loops before the ads. Then it lists the different items here. Oh, what's an item? I don't know what the item is. Probably some, oh, right here. Reclam, that's ads. So the media URL. We can actually do it like this. So we I think we can dump this. So B, do like this, requests txt to show. Oh, right. Increase the size here. Okay, so from format JSON to format JSON. Oh, okay. So we need to pipe it in perhaps requests. Okay, it looks better. Items. Tracking data. So if you want to optimize this for instance, for privacy parts, might be something interesting here. But let's see what we can do here. So let's see what kind of oh, look at this. So we have the metadata. It says different things here. Okay, I'll increase the more. So here you have some information about the event or the video, and we have an interesting field called hide ads, which is false. So let's see this. So we don't really know what this is doing right now. It requests these things, we know for sure, and then it probably parses it somehow, so most likely through a JSON parser, because this is a JSON file. And like the most common JSON parser is like the org.json library. Let's just quit this for now. So hopefully now I play anyhow. Yes. Okay, so let's use Frida trace. Connect to USB, frontmost app. Let's see if we can do something. I think this is the see if it uses JSON. So it has 35 functions. Let's try and play something. Right. Okay. Let's stop this. Okay. So definitely uses this one. Let's do like this. Grep for, what's it called now? Something with ads, right? Hide ads. So let's see if it checks for hide ads. Oh, wait. I need to launch the app. Let's play something. Okay, so it called the hide ads here, so we can see. So it initialized the JSON object with the data we got from the backend, the hide ads. Then it seems to call the JSON object opt boolean to get the value of hide ads. Okay, so let's just override the this JSON object opt boolean and see if we can make it return true and see what happens. So again, we do the perform. That will be the entry of our hook. We want to hook the class org JSON object. What's it called? Opt boolean. Oops. Opt boolean, and it seems to have probably don't want to do the same mistake again. So we say that this has. Actually, let's see if it has one or more. We can skip this for now. Do the implementation function R1, R2, console log patch function, and then we probably want to, all right, so we want to return true, but only, so if A1 equals has ads, was it has ads? Hide ads. Hide ads. So if I call the opt boolean of the JSON object and I want to get the value of hide ads, I want to always return true. If it's not hide ads, I want to call the original method. So something like this. And call this A1, A2, like so, right? So why is this complaining? Oh. Function. Okay, let's see if this works. All right, we probably want to see this A1, so print the name of the method that is querying. So let's see. I want to do Frida UFL TV4JS. See if this worked. Oh, of course, it just was an overloaded method. We knew that it is the one that also took the default value. All right, so we need to overload this one as well. Actually, I know I saved, so it probably gave me an error. No, it didn't. All right, I didn't come to that part. Okay, so now we should hopefully call the right method. So let's play something new here. Hide ads. Right, so now we didn't get the ads, I think. Let's try something else. See that it's called. All right, and it just jump directly to the stream. So yeah, that was another simple demo of how to use Frida. Okay, so say now that we want to apply this patch permanently. So right now we have the phone connected to the computer using USB. The phone is rooted, and we're using the Frida agent is running on the device. So ideally what we want to do now is to make a production version, or like something a bit more stable, of this patch. So we knew now that using Frida, we kind of figured out what we wanted to do. So now we can kind of do the same thing as we did kind of what we did in the previous talk when I did the static analysis. So you can do something like this. You can actually use, there's another tool called Frida PS, which lists all of the applications. That's an easy way to get the kind of the package name of the app. Then we use shell pm path, because we want now I want to get the APK. So we do an ADB pull of this one, save it as TV4 play APK, and then we do APK tool. We decompile it. I think since we only want to change the Smalley code now, it's an easy fix, so we don't need the resources, so we just leave them as is. The D is for decompile, preserve the resources, and give it the APK file. Okay, so now that I've decompiled the files, we can start to look where in the code it calls this, looks at this, kind of extract that value from JSON. So use something like grep and hide ads, and we look in the TV for play, Smalley, all of the Smalley files. You can see that it's on line 180 in this one. So we do let's open this file. Can search for hide ads. So yeah, so you can see here it's line 180. So here it has a string hide ads. It calls the the JSON object of the boolean, takes the result from that method and stores it in v1. So what we can do here is, instead of using the value from the return method, we can store something else here. So we want to put a 4-byte constant value into v1, the value hide add, so it's 1, so it's a boolean true, and we'll put the boolean v1. Okay, hopefully this will work. So you use the APK tool again. You do build T4 play. So compile the Smalley file into the DEX files again. Create the APK. Okay, now that it's built the APK, we can sign it. So I use a tool called Uber APK Signer. I will give it the compiled APK. We can install the APK. So I'll take the align debug designed. Now the app is called is installed. Let's launch it. Let's try something completely different. And it starts without the ads. Let's we can try something more. So no ads. So now this APK is patched. So and it's compiled. It doesn't have anything to do with Frida. So this app you can install on any device. It doesn't have to be rooted or anything like that. But this just shows that the time it took here to compile this app and put it into an APK again is kind of time consuming. So when we were trying things out in Frida, doing this in Smalley instead would have taken a lot longer time. So now we kind of again cut the workflow time in a lot. So yeah, that was the end of this talk and presentation, I think. Thank you for listening, and feel free to reach out to me over email or add me on LinkedIn. And I hope to see you at the next 0xFF event.